have a excellent concept, or we have to identify a concept for which the product is to be realized. Then we go through the industrial design process which he explained. Then engineering design, we have to look at the function and other things. And of course, in order to achieve this, we also have to give equal importance to the material selection, what material it is, what is the process that we have to follow. There are different processes of design. One can be a top-down approach and a bottom-up approach, which we will just go through now. And in order to realize the product itself, we may need to do validation, finite element analysis or validation, so that we don't spend a lot of time. In the initial stages itself, we catch any errors, any defects, and we are able to optimize the time to realize the product. And of course, in the process of achieving the final product, 3D printing, prototyping forms a very important step. And in order to get all these things, what are the emotional values that we give? Visual appeal, usability, serviceability. These things have to be kept in mind to achieve a good product design. Bringing an idea to life is conceptualization. Somebody comes to us with an idea, we discuss, we do some research, and then we sketch it. We make like Sunil was telling, we may do some minimum handmade prototypes, plaster of Paris, clay or something. We give some form to the idea. This is a concept, and it could be a prototype of a planned product or an initial design plan of working, a storyboard, whatever it is. We give a concept, and once this concept is realized, then we can take it forward to the next stage of design. I am showing a few concepts. A concept sketch of a vehicle, a clay model which has been made with the concept in mind, and many cases using this kind of clay models, an engineering model or a CAD model can be generated by reverse engineering processes, or a storyboard as below. We explain what it is. It may not be a very accurate sketch or a figure, but along with the images, we also give an attribute, or we explain what is the function of the things. So these kind of concepts can be used to get the message across to the customer or the client. The next stage to a concept is to make an industrial design. Industrial design can be a single conceptual design or multiple concepts taken into a visually appealing image. Good contours, great looking graphics to grab the customer's attention. It could be made in such a way that we use graphic software. It can either be 2D or 3D, and need not be considering the functional aspects. It need not, at the stage of industrial design, we may not give more importance to what is the function of the product or how do we achieve the function of the product. It appeals to the emotional quotient or the interest of the consumer who uses this product. It should be attractive to the customer. For example, we have a concept vehicle here. Now, achieving these kind of geometries would be very difficult other than by 3D printing or making some fiber molds and other things. But even then, looking at this kind of a concept, where to add the engine, where to add the transmissions and all will be a big challenge at the stage of industrial design. But once we go on with the engineering and other things, giving importance to functionalities, we may have to work a lot in achieving the actual function that this concept is expected to perform. This is one of a product, very successful award-winning product which we worked on. It is called the Trinetra. It is a camera for taking photographs within the eye. Now it looks very good on the left side, but if you see the right side, the optics and all have to be very mounted on a very complex internal mechanism. So this was given to us as an input, and based on this we had to work out in such a way that we are able to give a simpler methodology of mounting the optics, by which the cost also could be minimized and it could be achieved in a better way also. So we worked on this, and in the engineering portion of this we were able to achieve a method by which we are able to do this within about 1/10 of the cost of what it is being used here. So not only industrial design, we may have to be involved and work towards the engineering part of this as well. See, usually engineering and functional design, multiple industrial designs may be submitted for approval, and we work with the customer as to what is the suitable design that the customer is liking, and based on that approval we go on to the next stage of engineering or functional design. Here we work on the actual features involved, as he told, and what are the parts, features, electronics, connectors, cabling, how these things interface with each other, then how the interface, human machine interface or the human product interface happens. All these things will come in the engineering design. And not only that, we will also work on the fundamentals as to what are the loads or the stresses that will come onto the product, what are the materials that have to be used, and all these things will be coming under the engineering or functional design. I have taken a few case studies. This is a exoskeleton which has been developed. This also has a battery pack, and it caters to physically challenged people. It will allow them to move around. So these though it doesn't look very good, but on functions and the engineering aspect, it is really serving the purpose. And another very good engineering design is, this was again developed by a professor from NID. This is making use of cane, and it supports the laborers in moving the materials in the construction industry. Not only that, it also it can also be used as a trolley for it has some casters or wheels, and it can also be used as a trolley for dragging the things across, and it is low cost, doesn't look great, but serves the purpose. Pardon? Thank you. An important part of the product design process is the selection of materials. Different applications need different materials, and a very high importance should be given to the materials which are chosen. Wrong materials can actually create more problems than good in the process of the product design stage, and many well designed, actually the product design could be very good, but in case we use a wrong material, the success of the product itself may be compromised. I have taken a few case studies. Pistorius with the Blade Runner who came to fame. The prosthetics are all carbon fiber prosthetics. No other material has the springy nature, the lightweight, and the possibilities of doing this. And nowadays a lot of people have switched over to carbon fiber as a material in the sports industry. Cables, fire retardant cables, a sample photograph is shown. There are multiple sheaths to the copper, and specific fire retardant material polymers have to be selected, otherwise fire hazards can be a very costly affair. And especially in case of children, health products and all, if we don't use the right materials, it can be a disaster to health. So material selection is extremely important in the process of product design. And process selection. What process we follow in the product design stage? There are two specific approaches that two or three approaches that we follow. One is called a top-down approach, wherein the skeleton of the product is first designed and developed, and all the paraphernalia, the external parts are built around the skeleton. So the major important part is developed first, and then one by one, as it supports, we are able to modify the skeleton and attach the parts, or we design and develop individual products separately and then try to assemble it together. So that is called a bottom-up approach. But normally in current days applications where products are following a very integrated approach, there are not only products which conform to mechanical engineering, but we may have to have electronics, we may have to have some programming built into it. So in these kind of approaches, we may have to use a hybrid approach wherein we do certain things isolated and then try to integrate everything. This is a case study which we have taken. These are fiber optic splice units. The customer wanted us to develop it in such a way that, of course, they had given us a similar product. So these products, these are where all the splices will come and get assembled. First we had to develop this, and then we had to develop these areas in which this will come and get assembled, and these will be used by the cables and it will be assembled onto this, and finally the cover will be fixed. So though it was a very tedious process, we took almost a month and a half to achieve this. We were able to get it right the first time. So these kind of examples, we have used a completely top-down approach in this, and we were successful in achieving the product. Validation is a very important thing. See, nowadays most of the customers or companies are looking at developing products and realizing the products in a very short period of time. So in order to achieve these critical time frames, we will have to validate the product even before it is actually manufactured. So we use different tools, engineering, simulation, validation tools, so that we are able to assess the functionality of the product, see the stress values and other things even before the product is manufactured at the design stage. So some of the cases which cater to different industries are showcased here. This is we have done for a dentist, wherein the implant, the loading on the teeth is observed here, and whether the implant is design of the implant is able to take care of the load supplied, we have studied in this case. That is a very large scenario wherein a wagon tippler, coal is loaded onto a railway wagon. So the entire assembly was analyzed, and it was before fabrication. So only once we came to know that it will be able to withstand the enormous loads that are acting into it. That is a 140 ton wagon tippler. 140 tons are loaded onto that. Only then metal will be cut and it will be built. In this particular case, this is the cover of a steering wheel. We have done a mold flow analysis. It is for a plastic product. Before the plastic or the mold is made, metal is cut, we analyze whether it is going to fill properly, whether it is going to be manufacturable, and then only the metal will be cut. In that particular case, we have seen a conversion of a streamlined flow into a turbulent flow in case of a air blower, and once the CFD analysis has shown that it is correct, and then only we have gone ahead with the product design. So these cases showcase that simulation is a very important and useful tool in the product design process. 3D printing and rapid prototyping support us in case of visually seeing the part, feeling the part before it actually gets onto a manufacturing production line. In many cases we catch some of the problems in this stage, and with the advances in these kind of manufacturing processes now, even final products are being made by 3D printed processes. And one of the advantages here is, in case the number of parts or the products are low, small in number, it can save a lot of money in the tooling and other related costs. Some of the samples, 3D printing is extensively being used in the fashion industry now. Some very good looking lighting fixtures. The bottom right part is a fuel injection nozzle. This was developed by GE Aviation. Now this is a metal printed nozzle, and one of the advantages in this particular case or in this design is it has eliminated 18 individual parts and a single part is made, and it has saved 40% in terms of weight, and the performance is much better and than the entire nozzle assembly which was previously being used. And in these cases, a lot of people have been scanned, modeled, and it has been 3D printed. So it can be used as giveaways, takeaways. So the applications of this are many, and not only that, it is also useful in the product design process.
The different design approach is required for that?
For what, sir?
For 3D manufactured products.
Usually, in case you want to see the functionality of the product at the 3D printing stage, you may have to slightly modify the design approach, but tolerances and other things have to be redone for the manufacturing production activities.
Function as a, what I'm saying is these are like almost like a task product. Strength for example. Then we'll go for the question.
Visual appeal, as the saying goes, the first impression is the best impression. Good looking products add value and help in selling easily or at a premium. Some examples I have shown. These are products which were being, these were one of first few electrical products that was designed in Japan. This is a washing machine, this is a refrigerator, vacuum cleaner, and currently these are the shapes and designs of these things. This is one more handheld vacuum cleaner and a normal vacuum cleaner designed by Dyson. So Dyson is one of the very good companies which invests a lot in industrial design. So you can see how good looking it is and appealing this is. So usability, the appeal is not only important, how easily it can be used, that also matters. It should be user friendly, and once it is user friendly, the appeal or the success of the product also increases. Especially in India, there are a lot of people who are not very well educated, so they cannot read things, or instructions may be given in English which many people don't know in the rural areas. We have worked with CDOT, with the prevalence of mobile phones and other things. People who may not be literate also have to use the mobile phone. So in such cases, there have been user interfaces developed so that the usability of these mobile phones can be achieved by even the masses. and especially the deposit. One of the examples, I don't know whether I have it here. One of the examples is called the Norman door principle, wherein the doors which are available is not very user friendly. They would have given a handle, so people tend to pull it, whereas they should have pushed it. So these kind of there are small errors in design or lacunae in design which we can see in everyday activities, so that if we give importance, if we observe a bit more, we will be able to find out these things. And serviceability has to be looked into, like how sir showed, in machines, in products, especially in case of I have used Dell products, wherein most of the fasteners are done away with. It is extremely easy to service these products. You just click a button, the entire thing comes apart. You can remove the hard disks, the any of the internal parts, and you can assemble it back without any tools. So Dell, HP and these kind of companies have invested a lot of money in serviceability, because sometimes you may not have any tools to service these things. So this is one of the things, and communication is very important in design, especially when we don't have a MSMEs or small companies which work with external designers. So communication becomes a very difficult situation. And on the lighter note, I have a slide which sorry. The first image shows an image how a customer explained, a overseas customer explained it to a software engineer in India. The second design shows how the project leader has understood it and explained it to the analyst who has designed it. The designer has designed a swing in such a way, and the programmer has programmed it in such a way that in this manner, and the business consultant has described it like this. The project has been documented like this without the tree in place. The operations, when they have installed it, only they have installed one single rope. The customer was billed as if the entire theme park has been built up. It was supported like that. The entire tree has been chopped off, and what the customer really needed was only a tire against with a rope, so that children can swing over that. So this is what happens in case of good communication doesn't take place. And when design processes go wrong or teamwork goes wrong, this can happen. The same image I have also used. This is one actually success. I mean, this has taken place in Walt Disney themed pencils. They have developed pencils in such a way that the pencil is shaped in the Mickey Mouse head, but the eraser cannot be used unless it is taken apart from the pencil. So these are kind of wrong designs. The urinals and the staircase also you can see. Many people don't want to go against, implementing people don't want to go against the designers. So whatever the architect or the designer has done, they have just implemented it. So these are the things that can go wrong. And along with this, some of the applications, what we follow is design for quality. Quality is very important. So we have to design for quality and be qualitative by design. So unless if we don't give importance to quality, then the product will come bad. Design for manufacture, we have to consider the manufacturing processes in mind. If we don't do that, then the product will not be realized as we want it to be realized. and especially many of the companies, even the automotive companies, electronics companies in India are not very confident of getting things manufactured from manufacturers in India. One of the main reasons is many manufacturers don't give importance to quality here. So that has to change as a culture, and once we are able to do that, definitely more business can come here. One of the important things people nowadays are giving importance to is design for failure. Many cases people don't want a product to be long lasting, especially in the electronics field. So they put in